Welcome everybody. Today I'm going to be talking about Azure Geo-Replication for Azure SQL. I'm Roberto Bustos. I'm a program manager. We go on more details on that. Now, first of all, we have to discuss about business continuity. So business continuity is a key requirement to implement any business critical system. Not having a disaster recovery plan in place can put organizations at great financial loss, reputation damage, or customer churn. So natural disasters can happen, right? Hurricanes, earthquakes, or even man-made disasters like a war. And this could cause permanent loss of an entire data center or parts of a data center. Now, the good news is that the cloud has made easier for customers to deploy replicas quickly in very distant regions. And how can we accomplish that? Well, today I'm going to discuss about Azure SQL Geo-Replication, how we, as an Azure SQL, provide a solution where you can literally replicate, have a replica in the other side, in the other part of the world, if you want. Now, before jumping into the material, just a little bit about me. I'm Roberto Bustos. I am currently a Azure SQL program manager. I focus in active Geo-Replication and maintenance window. Before that, I was a cloud data and AI solutions architect here in Microsoft. Also been in Oracle as a senior cloud engineer, and also in MicroStrategy and JP Morgan, again related to the cloud in a BI cloud, and as a data analyst in JP Morgan. And in the more personal level, I mean, I enjoy sports, and I put there, I enjoy swimming, I enjoy playing squash. So this is something just a little bit about myself. Now, before jumping into a disaster recovery solution that we offer in Azure, first I want to put the difference between high availability and disaster recovery. So high availability is in the same region, right? And the replicas are synchronous. So compare this to disaster recovery is when you have a failover on the entire region, a natural disaster, and then you have a solution in a distant place that was not affected. And for that, we have, of course, asynchronous replication. And we have certain, of course, RPOs and RTOs numbers to ensure that your data, your recovery time objective, and how much data you will lose. Now, focusing now in the high availability, when you deploy an Azure SQL database and you choose a business critical, by default, it's going to come with 3 more replicas. So you deploy one database and total is going to be 4 databases deployed. And the reason is because you have the primary one is going to be your read and write database, and then 3 more replicas. One of these replicas can be used as a read only endpoint. And the reason of this is because, of course, if the primary fails, one of these replicas will take over, and we will have 2 more waiting in the case is needed. So failover is handled by the SQL Server database engine, and the workload are automatically redirected to the new primary node. So basically, in this case, you don't have to do anything. In the case of failover, all the workload will be automatically redirected into the new primary node. Now, we also have some redundancy. So basically, in the example we mentioned before, you deploy business critical, you deploy this primary and 3 more replicas. And I'm showing here in this slide how we place these replicas. So as you can see, we have availability zones in Azure. So we have zone 1, zone 2, and zone 3 in this case. So to understand a zone, basically these zones are into the same region, but they are separated. There are zones that are independent, cooling power, hardware, and even physically independent to each other. It could be even different data centers into the same region. And the reason of this, of course, is to have high availability. For example, as you can see here in the AC1, you have the primary and one of the secondaries. In AC2, another secondary, and in AC3, another secondary. So basically, you are protected into the same region in 3 different zones. And this is how we actually, place these replicas. So we ensure that if there is a problem with one of the zones, you have 2 more options to go ahead and have high availability. You don't lose continuity in your business. Now,
Roberto,
yeah,
the first question coming up.
yeah.
Stefan, do you want to unmute yourself and ask the question yourself?
Yeah, sure. Short question. For 1 main and 3 replicas seems a little bit over-engineered. Is there any experience, any heuristic behind that? Because from my gut feeling, I would place this as primary some in AZ1 and a secondary in AZ2 and maybe a third one in AZ3, and that's all. Seems a little bit over the top.
Yeah, well, I mean, I don't currently have the numbers. I can definitely search for them and show you how we plan this specific number of replicas. But yeah, typically, for high availability and specifically for databases that are in production, you want to ensure that there is no downtime. And there are, of course, businesses that require basically continuity all the time. They cannot lose almost any second in that. So, I mean, the first logic, of course, was to have 1 replica in each zone. Zones came after, like, that's something newer in Azure. But well, the good thing is you have 3 replicas, but only 1 is a read-only. And basically, the reason, at least to have 3, of course, in this case, in this example, is because at least you want 1 in each zone. Now, I can, of course, definitely search for more specific numbers, the numbers why we are having this number of replicas.
Let me give a guess. So we need 1 replica for patching, that's 1. We need then still need 1 replica for, let's see, being able to failover, and another one just as fail-safe. That's my guess.
Yeah, I mean that's that could be
sounds about right.
Yeah. Yes. Okay, so now I'm continue. And let me show you, this is very interesting because now we're talking only on the zone level. We're only talking at the same region. Now, what happens then when there is a disaster in the entire region? And that has happened, like sometimes we have outages, power outages, for example. And then the 3 zones are affected because the entire region have like a storm, a hurricane or something. So now it comes Geo-Replication. That means that we have another database that is being replicated outside in a different regions. And for this case, you can have up to 4 replicas. Now, I say up to because, as you're saying, in this case for Geo-Replication, if you want to deploy only 1, that's fine, and you can deploy up to 4 in different regions. And I'm showing here like a very simple architecture in the sense like, okay, you have this primary, the primary read and write, sorry. And then you have your secondary that is asynchronous replication. And in the moment you have a failure in the primary, you switch everything to the secondary. And then of course the secondary comes read and write in this situation. And I'm gonna show also examples how we can use this. So in the case of the primary, let's say you have a primary in East US, that is Virginia, the Washington, D.C. area, and then you have your secondary in South Central Texas in this case. So as we mentioned, in the case of a disaster in Virginia, you can fail over to Texas. Now, there is also other use cases. For example, let's say you have a customers or employees that need to do reporting in Texas, and they need to have reports with the low latency. So basically, when you deploy this secondary in this example in Texas in green, you're giving this database low latency in the same area where your customers or employees are, and they can run a lot of queries in low latency, and you're not affecting the performance of your primary database. For example, that's one of the use cases. Another use case, of course, is database migration. When you have to, you want to migrate your database to a different region, and basically you require minimum downtime. The same, you can create a replica, they start the seeding, and then basically you do a plan failover, and then you move the data basically to a different region in a very transparent, quick way. The other reason you can have that is for application upgrades. You can create an extra secondary as a failback copy during application upgrades, for example. Now, we mentioned that there is two types of failover we have. And one is the plan failover. So basically, the plan failover switches the roles between the primary and secondary databases after the full synchronization is complete. It is an online operation that does not result in data loss. The time of the operation depends on the size of the transaction log on the primary that needs to be synchronized with the secondary. And of course, as we mentioned before, plan failover is designed for to perform, for example, disaster recovery drills, to relocate a database, as we mentioned, or to return the database after a failover. You can return the primary to the original region. So plan failover is something that you don't lose data. You basically, when you start the failover, it won't do the switch until all the data is copied into the secondary. Now, we also have, of course, on-plan failover, and on-plan or forced failover immediately switches the secondary to the primary role without any synchronization with the primary. So any transactions committed to the primary but not replicated to the secondary will be lost. And of course, this operation is designed as a recovery method during an outage. So in this case, on plan failover, is something disaster happens and you don't have other option to do like a forced failover. Now, when the original primary is back online, it will automatically reconnect and become a new secondary. If you have unsynchronized transactions before the failover, they will be preserved in a backup file, but they will not be synchronized with the new primary to avoid conflicts. So basically, this group of transactions that are different between the two databases, you will have to manually merge them. You can maybe take this from the backups into the new primary to avoid any conflict. So Microsoft won't automatically, Azure won't automatically merge this difference between the primary and secondary in the case of an on-plan failover or forced failover. Now, GeoReplication at the end of the day replicates using transaction logs. We are not using, this is not transactional replication, which replicates using DML commands like insert, update, or delete. This is just by the transaction logs. And, and as I mentioned, we do asynchronous replication. And asynchronous replication means that transactions are committed to the primary database before they are replicated to the secondary database. Now, there is a way you can force synchronization in the replication. Let's say you want maybe to update some passwords in the secondary. So you want to enforce synchronization. We have a procedure called SP-wait for database copy sync. And basically we're forcing the synchronization. Now, this of course will impact the performance because it blocks the calling thread until all committed transactions are replicated. So this is of course only using situations where you wanna synchronize the database for a specific time. And then of course, just if you want to, for normal operations, you should leave it as a synchronous replication. Now, there is different ways you can interact with Geo-Replication, Azure Portal, PowerShell, Transaction SQL, REST APIs. And as I mentioned before, you can have up to 4 secondaries and are supported in the same or in different region. Now, it's up to 4, but of course you can only deploy 1 if you want. We believe that all production databases should have at least 1 secondary for your disaster recovery strategy. And I'm showing here an architecture in the left, you can see how the primary has 4 secondaries. And in the right, we have something called chaining. So basically, let's say you can actually create secondaries of a secondary And this will make an unlimited scale of database replication. You can have an endless number of databases. So if you look here, the primary is replicating to the secondary, that is the number one is one secondary. Then this number one, that is a secondary of the primary, is also replicating to number two and number three. This number two is replicating to another two databases, and then we can do a tree of multiple databases. I know you're thinking, why would I need that? Well, there is two things. One is sometimes the first reason is if you look at the left and you have the primary, is for each database that has a link, is using, of course, memory and CPU. So for example, in the primary in the left, it has to be replicated to 4 databases. So it's using more CPU and more memory. In the example of the right, the primary is only replicated to 1 database. So it's using less CPU and memory for this operation. Of course, this will increase the lag. So for example, between the primary and the last database of the tree, they have an increased lag in terms of how the data has to jump between many databases. Now, why would you want to have more than one secondary? There are many reasons. One, some customers, for example, they have in different regions replicas. They also are served as these are read-only. They are sometimes serving customers in different regions, in the south, in the north, in the other side of the world, and they are using for reporting. And then they have multiple secondaries to being able to don't overload the primary with all these inquiries, and also have low latency for customers in different areas when they want to query the database. Now, if we want to talk about Geo-Replication, we have to talk about auto failover groups. And what is auto failover groups? Well, auto failover groups feature allows you to manage the replication and failover of a group of databases. It is basically an abstraction on top of the existing active Geo-Replication. So basically, both of them use the same technology. I mean, auto failover groups is running on top of Geo-Replication, but they have different use cases. And I have this table, I'm gonna explain what 2 different use cases we have. Now, Geo-Replication or auto failover group, that doesn't mean that one is better than the other. They are just being used differently in different use cases. So for example, let's say if you deploy an Azure SQL managed instance, this is only supported in auto failover groups. And the reason is GeoDR, at this point, we only do GeoDR at the database level. And managed instance, we do at the instance level. It can have multiple databases inside. So basically, with auto failover groups, we can, the way we are doing it now is we replicate the entire instance, the managed instance with all the databases inside, to a different region. Now, we also have something called automatic failover, and this only works for auto failover groups. So basically, automatic failover, you're letting Azure to manage the failover in case of a failure. So the way it works is Azure triggers failover after a failure is detected and the grace period has expired. So basically, you can set a grace period. The minimum is 1 hour. And the reason is that it involves human action from our operation team. So when we have a failure, we first try to mitigate the outage in that grace period. Let's say you choose one hour of grace period. The primary comes down, and if you select 1 hour, in that hour we try to bring the primary back online. Now, if we can't bring it online, then after that hour we do the failover. So basically, you don't have to touch anything. This is done in an automatic way. Azure is doing it. We are doing it. Now, of course, if you want to do the failover in less than 1 hour, you say, okay, I need a failover now, even if I lose some data, because this was like a asynchronous on-plan failover, sorry. So you can always do the failover manually or through your application if you want. Now, these types of failovers, when we do the auto failover, we do it when, let's say we have a cluster-wide outage, like a power, network, or cooling failure, fire or flood, for example, and that's when we you utilize auto failover groups. That's something optional, or you can use it, or you can just manually do the failover when something happens, or your application can do the failover. Now, the third point is you can have multiple databases failover in a simultaneous way. You can do that with auto failover groups. With GeoDR, you can have the replica in the same or different regions. With auto failover groups, it has to be in a different region. When you create a replica, it has to be in a different region. And of course, both of them are read scale. That means that you can read from them to use for readings. The other interesting point is for GeoDR, the failover must be initiated manually by the application. And after the failover, the new primary has different connection endpoint. So you will have to change the endpoint. In the case of auto failover groups, we provide these listener endpoints, and they remain unchanged during the failover. So basically, when the failover happens, the listener endpoint doesn't change. You don't have to change the connection of your application or anything. It will remain the same. It will just be pointing to the new primary. Now, how do we compare to other clouds? How do we compare to other clouds? Well, I mean, I'm not intent here to compare everything and all the offers. So we're only talking about in this presentation about Geo-Replication. And for example, AWS, if you want to deploy in AWS SQL Server in RDS, for example, they do not support cross-region read replica. It has to be in the same region. And also, when you deploy in AWS your primary and your secondary, if you start having lag issues between these databases, let's say that the lag between start increasing 5, 10 seconds or even more, they do not mitigate this. Basically you will have to check why this lag is happening. We in Azure, when we have lag between the primary and secondary, we do take care of that. We take a look and see why this is happening, and we solve this problem. Now, AWS, they do offer cross-region read replica, but not for SQL Server. For example, if you want to deploy Aurora with PostgreSQL, you can actually deploy a primary and a secondary in a different region. This is in the case of AWS. Now, in the case of Google Cloud, they have something called Cloud SQL for SQL Server. And we're only talking in PaaS offerings. We're not talking about VMs or anything, only the PaaS offer. And in the case of Google Cloud, they do not support cross-region replica for the SQL Server engine. They do not. They do support it right now only for MySQL and PostgreSQL engines. With those two, you can have cross-region replication. So this only trying to compare if you want to run specifically SQL Server in other clouds, how do we compare in terms of geo-replication? So as we can see, I mean, GeoDR is a clear differentiator of Azure SQL. As in contrast with our competitors, we provide the ability to deploy multiple replicas in different regions. Replicas can be used as read-only to offload the workloads of the primaries. And also, you can, with availability groups, we can fail over multiple databases simultaneously. And we also have the option to use auto failover groups without the need to change the endpoint when a failover happens. And of course, and the main point is, at the end of the day, when we are using Geo-Replication for Azure SQL, we are using the SQL Server native technology, like always on. So basically, it is very well integrated. So these replications are very well integrated. We're using the same technology, native technology of SQL Server in Azure SQL. Okay, now I'm gonna do a demo, just pretty simple demo, just to show you, how to set this up, just to have you an idea of how will you set up your replication, how difficult it can be. So I'm gonna share my screen. Let me see. let's stop the share here. Okay. I will be sharing another screen. A second. Can you see my screen now? Yes.
Works just fine. Yeah. Mm-hmm.
Okay. So basically here in the Azure portal, and I created, you know, some some databases for demo. So we have here the Contoso server demo. We click here. Let me just modify this. Yeah. And as you can see here in this server, I have this database, and Geo-Replication is done at the database level. So here in this, you will find in data management something called replicas. And as you can see, I already have here a replica from East US to West US. But I will create a new one so you can see how simple is this. So basically, the only thing I'm doing here is say I want to create one more replica. I already have one. I want to create another replica. And let's choose another region. For example, we are in East US. We already have one in West US. Now I'm going to create one in South Central US, for example. Then basically I just select the region, review and create, and then we basically start the process of creating this replica. It will take some seconds. Part of the process is the seeding. Basically, we're copying everything there is in the primary into the secondary, and once that's done, then we can have the replica working. It's a quick process. Of course, it depends also on how big are your databases. Now, I'm going to show you here. For example, I have these two SQL Server Studio. One is pointing to the primary. The second is pointing to the secondary. So basically here, if I try to create something in the secondary, it's going to tell me, no, you cannot do this. This is only a read-only database. But of course, if I create in the primary, I can do reads and writes. And let's say I do this inserts. And you can see this database here. And you can see how this data is replicated. It's already in the secondary. I can keep adding in this first to the primary, keep adding inserts. And you can see how this is already in the replicated to the secondary. So this demo, I mean, there are many interesting demos we can do. I just wanted to show you how simple is from Azure perspective, just to have a GeoDR solution. Now, if you think you want to do a GeoDR by yourself on-prem, imagine you have to set up your hardware, choose when this is going to be, and of course, make sure that the hardware and maintain and the setup is running properly. And here is, you can see is very simple, and you can see the replica here. Let's see the status. Yeah, so basically we have now this main one in East US, and these two South Central and West US, two readable GeoReplicas.
Roberto, one question.
Mm-hmm.
Can you say something about the latency?
Yes. So basically, so between the primary and the secondary, the lag should be less than 5 seconds. So it should be less than 5 seconds. So basically, if a disaster happens in the primary, that means that you can lose up to 5 seconds of data. And in terms of a disaster recovery, they are so it's 30 seconds, the time it takes to bring back online another database. But yeah, so the lag is between the primary and secondary is around 5 seconds, 5 seconds or less. Okay, so I'm gonna switch again my screen. Let me see here. Okay, you can see my screen again, right? Mm-hmm. This was I mean, very straightforward demo just to show you an idea how quickly you can just set up this, and you know, and you have basically your DR solution already running. Now, what is in the pipeline? What is coming? Well, we have we have something where we have Geo-Replication for Azure SQL Hyperscale. And currently, this is in preview. Hyperscale service tier in Azure SQL database is a service that supports up to 100 terabytes of data size. That means that you can deploy very, very big databases, or actually very small. You can start very small. Then it's very flexible and elastic with hyperscale. So right now we are in preview. We have certain limitations like force and planned failover. We don't support yet in the preview failover groups for hyperscale, but once we are GA, we're planning, of course, to support failover groups, force and planned failover. The other thing we're working on is in the hyperscale database copy. Right now is also in preview, but of course it's going to be GA in some time. Basically, with this feature, you can, and this is specifically for hyperscale, this tier, this big tier of Azure SQL database, you can copy your database, and you can use this for deployments, testing, for example. Let's say you have your database, you create a copy. When you create a copy, basically you're creating another database that you can use for testing. You can do it in the same region or in different region. In the case of hyperscale, if you do it in the same region, it's very quick because we are using the same page server. If you do it cross region, it will take more time to copy because actually we are copying the entire data to a different region. But there are many circumstances why you will want to have a database copy, maybe testing, maybe development. You don't want, of course, developers to be maybe touching the production database. So this for hyperscale is right now in preview, or of course going to be in GA in some time soon. Now, if you want, of course, to get started with actually Geo-Replication, there is a way to do it without actually expending anything in terms of money. So basically, you can create an account in Azure that is for free, and you can deploy an Azure SQL database. We give it for you for 12 months free, up to 250 gigabytes, for example, database. We also have 25 services that are always free. And but in this case, the Azure SQL specifically is 12 months free. And also you can create a replica. We give you $200 credit. Let's say you deploy a replica, 100 DTUs is like one core, one V core with 500 gigabytes in storage. So you will have a replica for 1 month. So basically you can test your scenarios for free in Azure to see how it works, how's the latency, how do you set up the replication. And of course, I put here some information. We have a very great get started. We have videos, demos, samples, quick starts, tutorials, all type of things where they can walk you like step by step in how to deploy geosecondary. And yeah, so basically, I mean, that's it from my side. I mean, of course, I think with Geo-Replication, we recommend all production database should have at least one geo-replica for a disaster recovery strategy. And with Azure SQL, it's something that it can be done actually in a simple manner. So.